To the Super Memory for Schools program. My name is Ta Tim King Nyok. The lesson I introduce to you today is trapezium. This lesson consists of the following sections. The first section is the definition of the trapezium. The second section is about the properties of the trapezium. In these properties, you will learn about angles and sides. The third is what a right trapezium is. Before studying the trapezium, please look at the image. This is an image of a trapezium in daily life. We go to part 1, definition. A trapezium is a quadrilateral that has one pair of parallel opposite sides. The quadrilateral ABCD has AB and parallel CD, which are parallel opposite sides, so this quadrilateral is called a trapezium. Quadrilateral ABCD is a trapezium if AB parallel CD. Then AB is called the short base and CD is called the long base. AB and CD are called the legs. From B we draw a line perpendicular to the long base CD. This line cuts CD at H. BH is the altitude of the trapezium ABCD. The exercise: is the quadrilateral below a trapezium? Why? Let's look at the figure. I have 3 figures, figure A, figure B, and figure C. The answer, the first figure ABCD, is a trapezium. Why? Look at angles B equals 60 degrees and angles A equals 60 degrees. These two angles are alternate interior angles and they are congruent, so BC parallel AD. A quadrilateral has 2 parallel opposite sides, so it is a trapezium. Figure B. Angles G equals 105 degrees and angles H equals 75 degrees. They are supplementary angles. We conclude that GF parallel EH, so EFGH is a trapezium. The bases are GF and HE. In the last figure, we look at angles K equals 115 degrees and angles N equals 120 degrees. These two angles are in alternate interior positions, but they are not congruent. Angles I equals 75 degrees, angles N equals 120. They are in corresponding positions, but they are not congruent. Thus, figure C isn't a trapezium. Through this exercise, what can you say about adjacent angles? The answer is these adjacent angles are supplementary. A trapezium has the bases AB and CD, AB parallel for CD. Look at the figure. Question A, if AD parallel BC, what can you say about the pair AD and BC, the pair AB and CD? The answer, AD parallel BC, so AD equals BC. And AB equals CD. We can prove this by using 2 congruent triangles. Specifically, triangle ABC is congruent to triangle CDA, angle side angle postulate ASA. Thus, if a trapezium has 2 parallel legs, 2 legs will be congruent and 2 bases will be congruent. Question B, if AB equals CD, what can you say about the pair AD and BC and the pair AD and BC? AD is congruent to BC and AD is parallel to BC. You can easily prove that by using 2 congruent triangles, specifically triangles ACD is congruent to triangles CAB, side angle side, congruent postulate. This means if a trapezium has 2 congruent bases, those 2 legs will be congruent and parallel. We see that in a trapezium, if 2 legs are parallel, those legs will be congruent and triangles will be congruent. Also, if 2 bases are congruent, 2 legs will be congruent and parallel. Look at the figure. What is special about trapezoid ABCD? Trapezium ABCD that has angles A equals angles D equals 90 degrees is called the right trapezium. Thus, a right trapezium is a trapezium with one right angle. We have an exercise. Find x and y in the trapezium ABCD, having the base AB and CD. The answer, AB parallel CD, because ABCD is a trapezium. So angles A plus angles D equals 180 degrees, two adjacent angles. Then you can see x equals 100 degrees. Similarly, angles B plus angles C equals 180 degrees, two adjacent angles. You replace angles with the measures and get y equals 140 degrees. In figure B, AB parallel CD, because ABCD is a trapezium. So angles A equals angles D, two corresponding angles. Thus x equals 70 degrees. Similarly, A equals D, two alternate interior angles, so you get y equals 50 degrees. In figure C, AB parallel CD, ABCD is a trapezium, so angles A plus angles D equals 180 degrees, two adjacent angles. So we get x equals 115 degrees, angles B plus angles C equals 180 degrees, two adjacent angles. So we get y equals 90 degrees. Please look at the exercise on the board. There is a trapezium ABCD with bases AB parallel CD. Given angles A minus angles D equals 20 degrees, angles B equals 2 angles C. Find the measures of all angles of the trapezium. The answer, angles B plus angles C equals 180 degrees, because AB are parallel CD and those two angles are adjacent angles. Angles B equals 2 angles C, so 3 angles C equals 180 degrees, and we get angles C equals 180 degrees over 3, which means angles C equals 60 degrees. Angles B equals 2 angles C, and angles C equals 60 degrees, so angles B is 120 degrees. We have angles A plus angles D equals 180 degrees because they are adjacent angles, and AB parallel CD. Angles A minus angles D equals 20 degrees given, so we will get angles A equals 180 degrees plus 20 degrees over 2 equals 100 degrees. Angles A equals 100 degrees, replace angles with the measures, so we get angles D equals 180 degrees minus 100 degrees equals 80 degrees. Now we go to the next exercise. The quadrilateral ABCD has AB equals BC. AC is the bisector of angle A, and we need to prove ABCD is a trapezium. Look at the figure. To prove the quadrilateral ABCD is a trapezium, we have to prove the quadrilateral has two parallel opposite sides. We need to prove AD parallel BC, which means you need to prove angles A2 equals angles C1. However, these two angles are in alternate interior positions, so AD parallel BC. Now let's find the way to prove angles A2 equals angles A1. We can write angles A2 equals angles A1, so we need to prove angles C1 equals angles A1. Y is angles A2 equals angles A1. The reason, AC is the bisector of angle A, so angles A2 equals angles A1. Angles A1 equals angles C1 because triangle ABC is isosceles with AB equals BC. Why is ABC isosceles? Look at the given information. It gives AB equals BC, so ABC is isosceles. I have already solved the problem. I will summarize the content of the lesson. Today you have learned the lesson trapezium. What is a trapezium? A trapezium is a quadrilateral with two parallel opposite sides. In this figure, AB is the short base and CD is the long base. BH is called the altitude. Two legs are AD and BC. The properties of trapezium. Firstly, two adjacent angles are supplementary. Secondly, if two legs are parallel, those two legs will be congruent and two bases will be congruent. If two bases are congruent, two legs will be parallel and congruent. Finally, a right trapezium is a trapezium with a right angle. My lesson ends here. Thank you for your attention. See you in the Super Memory for Schools program next time.